Okay. Let me introduce myself. Pico. My name is Claudio Oliveira Egalon. Okay, I am originally from Brazil. Originally from Brazil, and I have been in the States and have been in the US since 1985. So we're talking about 85, 40 years, right? 41 years. It's going to be 41 years in August of this year. Okay, I have been teaching at LAHC, have been teaching at LAHC since 2009, and that's going to be 17 years. But I have been teaching at the community colleges in California since 2003. But I have been teaching at community colleges in California, plural, right? Colleges in California since 2003. More students coming, go. I have a PhD degree in physics, 1990, from the College of William and Mary. And Mary, the city is Williamsburg, state of Virginia. I do not know if you know that area. It's like 3 hours and a half south of Washington, D.C., Williamsburg. 3 hours and a half, 3 hours, more or less. And I have a second PhD degree in electrical engineering. That's 1996 from Old Dominion University. The city of ODU, where ODU is located, is called Norfolk. It's nearby Williamsburg as well. Must be like at most 1 hour, maybe 45 minutes by car. Long time I haven't been there. Okay, you may want to take a look at the map, right? Just to locate yourself. Those Google Maps are really nice. Goes, we go Williamsburg. Williamsburg. There you go. This is the east coast of the states. Here you go. That's the state of Virginia. And let me remove this one here. Delete it. Yeah, place mark. Washington, D.C. is, let's see, Washington, D.C. is right in here, right? A little speckle. The District of Columbia is a very small speckle here in the map at the border of the states of Virginia and Maryland. And the city of Norfolk is right in here. There's a big naval base there in Norfolk. And there is also a city of Hampton. I do not know if you have heard of that. I spent most of my time doing my PhD there in Hampton because I was doing my PhD at NASA Langley. Williamsburg, Hampton, and, and the ODU is located here in Norfolk. William and Mary is located here in the city of Williamsburg. Okay, Williamsburg has a very William Mary has a very nice campus. Okay, Hampton has also another big base, an Air Force base. Let's see if we can get that here. And next to the base, here you go. That's the Air Force base, Langley Air Force Base. Next to the Langley Air Force Base, we have NASA Langley Research Center. That's where I spent my doctorate, doing my PhD, and then working at NASA after my PhD as well. NASA Langley was the first NASA center. Next to NASA Langley, we have this Langley Speedway, just in front of the NASA gate, the main gate. Okay, that's the campus of NASA. The Air Force Base is much larger than NASA. You go. And
Professor, sorry, I have a question.
yeah.
Yeah. Are you screen sharing?
Oh, yeah, that's right. Just thank you. Thank you for letting me know. Let me share here.
Sorry. Okay.
Thank you. Sometimes I forget that. Right? Here you go. Screen. Okay, so let's do that again. Okay, so here you go. One more student coming here. Here you go. Here is the map of the US, right? Virginia. Washington, D.C. is right in here at the border with Maryland and Virginia, the state of Virginia. Williamsburg. The College of William Mary is located in Williamsburg. It's a very nice town. They reenact the times of the colonies there in Williamsburg. Yorktown is right in here. It was the first settlement of English language in the States, and the city of Norfolk, where Old Dominion University is located. Right, I did my PhD in electrical engineering here, and the city of Hampton. The city of Hampton, where the Langley Air Force Base is located, as well as NASA Langley. This region is called Hampton Roads Center. Hampton Roads, the Hampton Roads. Hampton Roads Center is something else. Okay, it's also, this region is called the Tidewater region. There in that region, we have another very nice town that I like. It is Virginia Beach. Have very nice beaches there in Virginia Beach. I used to go there to enjoy the beach. Okay, and here's Hampton, right? Naval base here in the city of Hampton. So just for you to have an idea. And what's nice about NASA Langley, I would like to share that with my students. Okay, I am a history buff, and what's nice about not just about NASA Langley, but also about the College of William Mary, right? The College of William Mary is the College of William Mary is the third oldest college in the States. It was founded in 1693. Founded in 1693. Okay. So Old Dominion, what's Old Dominion University? Old Dominion University, ODU, used to be the engineering college of William Mary. William Mary today doesn't have an engineering college any longer because, the College of Engineering split from William Mary and formed the Old Dominion University, okay? And what about NASA Langley? NASA Langley was the first NASA center. It was its headquarters during the beginning of the space program. So that region has lots of history. not only Yorktown, which was the first English-speaking colony in the Americas, but all these colleges, right? The William Mary was one of the oldest one. NASA, that was part of the history of aviation and space as well. And it was there at that region, the Tidewater region, right? Hampton Roads / Tidewater region, around Hampton Roads, Tidewater region, where the original 7 astronauts from the Mercury program used to work and live. Even today, we have streets named after them. We have like Shepherd Boulevard there in Hampton, Glen Boulevard, and so on. So there's something else about NASA Langley. Before NASA was ever created, right? Before NASA was created, we had NACA. I do not know if you have ever heard of NACA. NACA was the National Advisory Committee on Aeronautics. You can check that in the Wikipedia. The National Advisory Committee on Aeronautics, which was founded by one of the Wright brothers. Okay. And then after the Second World War, and also after the Soviet launched satellite, the American government decided to create a civilian space agency. And one of the centers of NACA became NASA. Let's take a look at NACA. NACA, Wikipedia. National Advisory Committee for Aeronautics, right? For Aeronautics. It was at the beginning of the aeronautical program. It was founded in 1915. What, 10 years, a little bit more than 10 years after the first flight by the Wright brothers. Okay, during World War II, NACA was described as the force behind our air supremacy. Okay, also NACA also helped in developing the area rule that's used on modern supersonic aircraft. Modern supersonic aircraft, they must fly in certain places, right? And conduct the key compressibility research that enabled Bell X-1 to break the sound barrier. The first aircraft to break the sound barrier was the Bell X-1. Loss of history. Okay. And the research, here you go. Langley Memorial Aeronautical Laboratory. Samuel Langley was one of the aviation pioneers. And he was named, and the center was named after him, city of Hampton, Virginia. And then there are other, NACA had other laboratories as well. The one in California, nearby San Francisco, Moffett Field. Today is NASA Ames Research Center. We had another one in Cleveland, Lewis Research Center. Today is Glenn Research Center. It was named NASA Lewis Research Center in Cleveland, Ohio, and then later on was renamed as Glenn Research Center after the senator that flew in space, right? One of the Mercury astronauts. And we had the Muroc Flight Test Unit, which is the Edgewater Air Force Base in California as well. Those two are in California, right? Ames in California, nearby San Francisco. Muroc Flight Test Unit is in the desert, in Palmdale, nearby Los Angeles. Now, I have been there several times. Today is NASA Armstrong Research Center. Yeah, They named after Neil Armstrong. Okay, let's see when NASA was created, right? Wind tunnels, influence, blah, blah, supersonic reason. Here's the Bell X-1 aircraft. It had this color, the orange color, just called the Orange Beast by the people that used to work with the program. And chairman, let's see, Vannevar Bush, transformation into NASA, Special Committee on Space Technology on November 21st, 1957. NACA's director established a Special Committee on Space Technology. The committee also called Stever Committee. So Werner von Braun, technical director of U.S. Army's Ballistic Missile Agency. Okay, Werner von Braun was a German that used to work for Hitler, for Nazi Germany, building rockets to bomb London during the Second World War. And when Nazi Germany fell to the Allied troops, Werner von Braun decided to surrender to the Americans. He had a choice to surrender to the Americans, to the Russians, to the British, and to the French. But he decided to surrender to the Americans, and he was brought to the United States, here to the United States, as a prisoner of war. It's a very interesting history, you know. And then later on, even though he was brought to the States as a prisoner of war, right, like someone that was an enemy of the United States, eventually later on, he was given a very influential position at NASA. He became the director of the largest NASA center, which is Marshall Space Flight Center. But before then, he had other positions too. Okay, he was technical director, U.S. Army's Ballistic Missile Agency, that later on became NASA Marshall Space Flight Center. So here you can take a look, and the thing is really nice. I like to cover that with my students. So I work at NASA Langley let me tell you something else about Williamsburg before we talk about NASA Langley. Okay, just recently I found out that I didn't know that people wouldn't tell me that William Mary. William Mary is considered to be one of the public Ivy League colleges, right? There are the Ivy League colleges that are private schools, and then there are the public Ivy League. William Mary is one of them. And when I was working at I worked at NASA Langley from 1987 through 1996, through 1996, 9 years. Part of it, I did my doctorate there at NASA Langley. And that's where that was the place where I was introduced to the technology I work today, which is optical fiber sensors. Okay. So I have experience in firsthand. I had firsthand experience. I have been having, right? I have been having firsthand experience with innovation. Today, at that time, innovation was not as important as it is today. Entrepreneurship was not as important, but it has been gaining innovation and entrepreneurship. Today we call it the movement for innovation, and which is very important. People didn't didn't give much attention to that until the fall of the Soviet Union. Okay, it's interesting how the fall of the dismemberment of the Soviet Union, how influential it was that in the world, in the whole world. When the Soviet state was dismembered, the whole idea about capitalism and entrepreneurship really took root in society. And that became the priority for every nation. Nowadays, every university in the world, almost every university in the world, has a center to incubate small businesses. We didn't used to have that at that time. So that's happening all over the world. Okay. After the fall of the Soviet Union, the innovation movement took root in the world with the creation, of several business in, with the creation of not several, but let's say business incubators at several universities throughout the world. Okay, and that has been very important. This movement for innovation. Let's put it this way here: movement for innovation. We can say that the movement for innovation started in the late 1800s with Thomas Edison and other people, but it really became generalized throughout the world after the fall of the Soviet Union. I discuss all of that in a book of mine that I have published. Okay, and let me show you here. It's not a requirement for this course, but I just want to point that out to you. Okay, folks, you can, if you are interested, you can look at it. It tells me that this book tells the whole story of the development of the technology that I pioneered there at NASA. Let's see here. Transformation, the name of the transformational discovery. Transformational discovery. Let's see, along. Yeah. Let's see here. Here's the site here's the business I collaborate with, Bioinvestigations. This is a venture capitalist business in Connecticut. Okay, and that's the book I just published recently. I'm proud of that. It's just the volume 1. I plan to keep on telling the story. It tells the whole, my first years developing the technology that I have discovered and patented. Okay, it's available on Amazon.com. And so if you're interested, you can take a look at it. And we can talk about that too, if you have any questions about it. Okay, and that's a transformational discovery, right? I published this book both in the States and in Brazil, my journey of innovation through space and time. Okay. Since we're living at a time where innovation is something important, now I can share with you my innovation journey when I was working at NASA. It's an interesting situation because when I was at NASA, I never had any idea. I have never any desire to be an entrepreneur. I thought I was going to end up being a government employee or even a university professor. But little I knew about what the future was reserving for me, right? And with the innovation movement for innovation, I ended up becoming an entrepreneur while at the same time I do part-time teaching at LA Harbor as well. Okay, and it has been a very interesting journey. I learned things that never imagined that existed. Okay, the movement for innovation helps you is responsible. You know, the movement. I can say that the movement for innovation. Uh, movement for innovation is responsible. And let's see, helps us. Let's put it this way: helps us think outside the box. Have you thought about that? It's a very important skill to develop, how to think outside the box. You know, and I struggle with that when I was at NASA, not just because of me, but because the people that surrounded me. My boss, for instance, at NASA, he couldn't think outside the box. There are those people that they just think in terms of the things that they know of, they are familiar with, and they don't see the obvious solution, what seems to be obvious, not the obvious solution, but what seems to be obvious to some that can help you solve problems. Okay. And I went through the whole thing that helped me develop this technology that I have right now. Okay, which is an optical, a side illuminated fiber optics technology. Okay, we call it SIFO. Okay, it uses concept of physics, and we'll be able to cover that. Okay, so what's SIFO basically, and I explained that in the book as well, right? What's is SIFO is no an optical fiber. Let me give you an example of an optical fiber here. Let's go to my website, Science Sensors. Here you go. Here's the website of my business, Science and Sensors Technologies. Okay, at this link right in here, a waveguide kits. Okay. The whole thing about side illuminated technology is how we couple light into an optical fiber. What you see right in here is just is a model of an optical fiber. We call it a waveguide. Okay. Most optical fibers, how they are used. Most optical fibers, we use the light source to inject light here at the fiber tip. Okay, at this, instead of most optical fibers, we illuminate the tip of the fiber, the end of the fiber to trap light here inside. What I discovered was that instead of illuminating the fiber at the fiber tip, we could also do something, do many things better by illuminating the fiber from the side, and that's exactly what you see here. I have the laser pen that's illuminating the side of my fiber. Okay, and you can see some of the light is captured here inside and is transmitted to the other end of the fiber. Okay, that was my contribution to the field of optical fiber sensors. Side illumination of an optical fiber that has several applications, and that's what's covered also in my book. I think it's important to share that with you because one day you folks, you will be involved with that as well, right? Most likely you will have to create your own business. You have to go into become an entrepreneur, right? And hopefully you also discover something important that you will be able to commercialize. This picture was taken in 2014. I started working with this thing back in 1987. With this type of technology back in 1987 during my PhD at NASA. Okay, so that's what side illuminated is all about. Here is one model. Here's another model here. I discovered that if you taper the optical fiber, if you turn it into let's say a cone, you can get far more light captured inside the fiber, and I patented this idea. Okay, you can see that light is far more intense here inside, right? And propagates for much longer lengths compared to the other fiber that's not tapered, compared to the other waveguide, right? The right word for that is a waveguide. Okay, and that's if you go to our syllabus, right? Well, here you go. That's going to be part. This topic is going to be part of our course as well. The basics of optics, right? It's going to be taught here during this course. And once we cover this material, you'll be able to understand better what side illumination is all about. Mirrors and refraction, okay? Even optical fibers we cover here in this course. Any questions about that? Just a quick introduction, right? What I do. Now, let's go back to NASA and a new way of cipher, right? Side illuminated fiber optics, the new way of using optical fibers. At this point in time, I have 81 patents on this topic in 44 countries, and very soon I will exceed 100 patents in 7. Very soon, very soon, I will have. Thank you, Pedro. I will have more than 100 patents in 70 countries. Okay. Anybody has any, let's say, desires of becoming an entrepreneur in the future? I want to hear from you. You know? Oh yeah, Tapahanak. Yeah, Tapahanak. I remember. Tapahanak is the city, right, Jeremy? Yeah, we used to fly there. I used to take flight lessons there Jeremy said about. I do not know if you saw his message, right? He's mentioning about Tapahanak. And let's take a look there at Tapahanak. When I used to fly there I used to take flight lessons there at Langley Air Force Base. And I remember that we used to have a VOR there at Tapahanak. Let's write down here Tapahanak. Tapahanak. So do you know that region, Jeremy? Tapahanak. Here you go. You every summer you go there. Okay, that's not. Yeah, here you go. Tapahanak. That is. Let's see. That's close by. Let's see where this thing. Yeah, I had to. Yeah, that's right. I believe they have a VOR there. It's a navigation point where we use for airplanes at the time, right? And that's closer to Washington D.C. right in here. Yeah, this name is familiar to me. I used to fly nearby there. Yeah, that's right. Yeah, we have a river here, right? And that's the Tappahannock River, I presume, right? Yeah, I believe that. They do have a small. Let's see if they have. We can see the field here. Maybe it's this one. It looks like the field is this one. Uh, it doesn't say anything. No, it shouldn't be the field. The field. Let's see, Tappahannock Airport. Let's write it down here. Airport. County Airport. Yeah, here you go. That's the one. That's the one. Okay. Should be this one, right? Tappahannock Essex County Airport. And yeah, it's very far away from the city, right? Very far south. This thing look like an airport, but it's not. Definitely it's not. But the airport that you're mentioning is this one here. We have so many airports here in the United States. Amazing. Okay, so let's go back. And I founded the LA Harbor Physics Club. Okay, Physics Club. Now the Physics Club is a little bit it's not active anymore. Okay, and the meetings of the Physics Club we're doing experiments. Okay, when where we used to do experiments with these side illuminated optical fibers, fiber optics, or optical fibers. Okay, I even published a paper with my students several years ago, 10 years ago, which was back 2014. We used to do lots of experiments with that. And now I'm trying to license this technology to big corporations. At this point in time, I'm talking with a group of attorneys there in United Kingdom. And it seems they have a very nice offer for me to license my own technology. Okay. So here you go, my expertise in optical fiber sensors. Okay. I started working on this field in 1987. 1987, doing my PhD at NASA. In case you're interested in finding out more about my work, check this website here, Science and Sensors Technologies. And you can also search for my patents. Okay, you can also search for my patents in the internet. The site that I'd like to use for searching for patents, there are all sorts of good sites there. There are all sorts of good sites. Search for patents, okay? Then we have the USPTO, United States Patent and Trademark Office. We have the EPO, the European Patent Organization, okay? And many others. But the one I like the most, and many others, but the one that I like the most is the Google patents. Okay. Google patents, if you go to let's go there to the google.com. It's going very slowly for some reason. It's taking too long. Okay, let me try Google patents. Just type Google patents. Let's see if we will get, okay, now we get much quicker. See that? I do not know why this one is taking so much time to go to google.com, but here you go. In Google patents, you can search for almost any patent in the world. Even Japanese patent, Chinese patent, Google has a translation for those patents for you, okay? If you type here Egalon, you're going to see all sorts of patents that I have out there. EP is for the European Patent Organization, US is for the USPTO, CN stands for China, JP for Japan, AU Australia, BR Brazil, CA Canada, and so on, okay? ES is Spain, A2 is Hungary, IL is Israel, MX is Mexico, New Zealand, Philippines, Poland, and so on. That's just one of my patents that were published in several countries. If I go to the Japanese patent, right? Here you go. Here's the Japanese patent. It's you can see it was translated. Originally, it was in Japanese. This patent was in Japanese, so the Google website automatically translates from Japanese to English. And if you also go to, let's see, I don't see the Chinese. Let's go to Spain. Oh, China is here, right? Let's see. That's Chinese, right? Okay, here you go. The text is originally in Chinese, and the software, Google software, automatically translated it to English, and so on. Here you go. Here as let me show you one of the illustrations, right? Here you go. Here's a drawing of an optical fiber. Fibers are usually, the light in the optical fiber are usually inputted at the fiber end face here. You shine a light here at this end. That's what most people do. But what I discovered is that we can illuminate a fiber from the sides. And this box that you see right in here is just a light source, an LED, for instance. Okay, so that I want to share with you. And okay, every now and then, what I want to tell you as well, in addition, that was part of my introduction here to you, right? And let's talk about the course. Every now and then we have power outage here in the place where I'm teaching. Power outage in the place where I'm teaching, okay? When that happens, please do not log out since I have a backup plan. So stay logged in online, okay? So, and how do I go around this problem of power outage? Some of you may already know. There is a nice device called a UPS device. It's UPS does not stand for United Postal Service. No. Well, United Parcel Service, right? That does not stand for United Parcel Service. It stands for uninterruptible power supply. Okay. And what this thing is all about is just a backup power supply that kicks in whenever you lose power. So I have two of those here installed at my place. Every time that we have either a blackout or a gray out, the UPS device takes over and I stay online. Okay. And I suggest that you also buy one of those for you, right? In case that you are logged in and doing whatever you want, you not just to attend the course, but doing whatever you need to do. You know, purchase one of those in case that you lose power there at your place. And those UPS devices can supply power for, depending on the amount of charge it has, can supply power for 1 to 2 hours. Okay, just enough until the light returns. I think it was very good device to have, depending on the type of UPS device. Let's write it down here. Uninterruptible power supply. Here you go. Here in Brazil, we call it no breaks. Okay. In the state, we call UPS, uninterruptible power supply. Wikipedia has an entry. An interruptible power supply or interruptible power source is an electrical apparatus that provides emergency power to a load when the input power source or mains power fails. So they look just like that. I have 3 of those here at home. Okay, one to a computer of mine, another one to another computer that we have here, and another one that I use in my hydroponics plantation that I have here in my apartment. I grow lettuce here in my apartment using the hydroponics technique. And I use my sensors to monitor the water level in my water tanks here at home. So I strongly recommend that you purchase one of those. It's very easy to use it. Okay, though all those price that you see here is not in dollars, it is in Brazilian reais. So the price of those things can be anywhere between, let's see, $70. This one is around $70, 348 reais. But it can go as high as, you know, $100, even more. The one that I bought was like okay, this one is 2,300 Brazilian reais. It's like $500. But you have even more expensive than that. Okay, like those Tesla batteries, right? Those Tesla batteries, just like a UPS device, it should cost $20,000. Okay, so you have a small UPS device and very large one that can supply power for a very long period of time. And depending on the size of the UPS device that you buy, it's going to be rather inexpensive. So here we go. It's not a generator, right? It's a battery. A generator is different. A battery stores electricity. A generator produces electricity. So the UPS device, like I said, is just like a battery. Generator is not a battery, okay? Because it requires moving parts to produce energy, whereas a battery does not require moving parts to produce electricity. So we start at 9:40. Okay, right now it is 10:28. We'll be here until 12:50 p.m., right? And very soon I'm going to start covering my syllabus. So what we do for every hour of the class meeting, we take a 15-minute break. Otherwise, you may get burned out. Okay. I usually ask the students to do some introduction, okay, but this time I don't want them to do that because I want to start covering the material. But tell me here in the chat, instead of going for the introductions, tell me in the chat if you have any desire, right, to pursue an entrepreneurship career, right? Entrepreneurial career. And I want to hear from you, right? Or even better, what are your plans, right? What are your plans? What are your professional plans for the future? For the future, right? Do you want to teach, right? Do you want to teach? Do you want to teach? Do you want to get a government job, right? That's what I want to do. Government job, right? Or do you want to go for a business? You want to found your own business, right? Do you want to found your own business? develop your own business. Uh-huh. Private practice. Okay. That's nice to hear from you. I grew up at a time where the government would hire lots of people, right? But now that we're living in a world completely different from the world that I grew up, it's very difficult to get a permanent job at the school or at the government, and the and then we're being all geared, taught to own our own business. And I can see policy. Okay, Mikara wants to pursue a master degree in marine biology and policy. Okay. And then after the master, Mikara, do you plan to open your own business? Do you plan to get a permanent job? Right? What exactly
Excuse me,
that
Professor.
do you think you would like to do? Right? Dana, I would like to become a doctor. Okay. Open my own private practice. Yeah, that's entrepreneurship, right? Serving impoverished community. That's nice. Okay. I plan attending medical school. Okay. Hopefully my private practice. Okay, at least two entrepreneurs here. Pathologist assistant or medical lab scientist. In your case, Kimberly, would you like to be hired by the government to practice your profession, right? Would you like to be hired by a hospital, right? Or you want to pursue your own
Excuse me, Professor.
your own business, right? Let's
Excuse me.
see. Someone, Mirage, do you want to say something?
Oh yeah. I just had a quick question. What are the chances of talking to you right after the class, one on one?
Okay, you want to talk to me, right?
Right. Yeah.
Okay, good. Yeah, we can do that.
Okay.
And
Awesome. Thank you.
okay, radiologist. Okay, that's medical science, right, Susan? Mhm. Pediatrician. I plan to become that. That's nice. Okay. Construction management. Arians, construction. Okay. General contractor should be, you'll be owning your own business. Okay, Kimberly. Okay, thank you, Kimberly. Government or the hospital in the future. Okay. Let's see other students here. Okay, that will give me an idea where you want to go, right, in the future. And so what I want to do, 3:30, let's see, 10:34. Let's talk a little bit more, right? I want to start covering the syllabus right now. And let's cover the syllabus right now. Right now. Okay, so here you go. My name is Claudio Oliveira Galon. Okay, here's the college mission. I have the college email address, but I also share my personal email address with the students, with my students. If you need to reach me with urgency, I prefer that you email me to my personal email address because I'm always checking that. Here's the classes scheduled. Monday from 9:40 to 12:50 in Zoom. That would be the lecture.
Um,
Yes,
I have a question.
go
Will
ahead.
we have will we have a copy of the syllabus?
Yeah,
on Canvas?
yeah,
Or
yes. Yeah, let's go there to Canvas so you can see where it's located. I uploaded everything there, but it's not in an obvious place. I tried to put it in an obvious place, but I couldn't. So, but once I tell you where it is, you won't be able to. Here you go. You won't have any problem. Here you go. Physics 7, 2000. Thank you for asking. By the way, here you go. There is the home link, right? But the home link has nothing here, right? If you click the syllabus too, there's nothing here, right? So I tried to fix that, but I couldn't. So what I ended up doing, you should click on modules. If you go to modules, here you go. If you're viewing like a student, right? Let's take a look. As a student, you should, let's see here, modules, just below the syllabus. So the first document at the top is the syllabus. Everybody can see that. I'm in Canvas right now. Syllabus is here, right? I put here the study guide for the exams. Here are the notes. The notes that I have here is the notes for the 2025, spring 2025 course that I taught. And throughout the semester, I'm going to keep on posting the notes that we develop for the 2026 spring semester, okay? Lecture and lab videos. And again, those are the videos, the lecture and lab videos for the spring 2025. And if you click here, you're going to have a link for every class meeting, but that's the class meeting of the year 2025, okay? And as we move along throughout the semester, I'm going to create links for each of the classes that each of the class meetings, right, that we cover. Okay, everybody was able to do that, to check that?
yes.
Okay, so here you go. Modules, let's go back to modules here. So the secret here, right, is to look at the link for modules. And the syllabus is right in here. You can even download the syllabus for you to your computer. Let's see, those two documents are important for our labs. That's why I put physics lab. And I'm gonna cover this flyer here for the homework. Okay, going back, reset, leave student view. So that's the main page that we are going to be using. As the semester goes along, I'm gonna post also the assignments, the exams, the partial exams. Many of you who took the course with me already know how I teach this course, right? So, and those who didn't take my physics 6, I will help you out understanding how we do everything here. Let's go back to the syllabus. Here you go, syllabus. The syllabus document here is a PDF document. Once you open it, it's going to show up. Here you go. I suggest that you download this document to your hard drive. Don't keep it there in the cloud. Okay. And we are going to cover as much as you can before we go for the break. So here you go. Lecture office hours. Office hours from 12:50. Okay, from 12:50 to 1:50 p.m. Let me fix that. It's just a minor mistake there. So that's going to be version number 2 of my syllabus. Okay, good. 12:50 p.m. to 1:50 p.m. That's my office hours on Monday. Wednesday from 12:50 to 1:35. Same Zoom link. We'll be using the Zoom link at the below Zoom link, right? Not the above, the below Zoom link. Zoom link. That's the Zoom link here. That's the link we use for all the meetings and for all the lectures, labs, and office hours. Some of the students pointed out that this meeting, this link says about the summer. Don't worry about the summer. Okay, it's just in there. Just ignore if you see something in the link saying summer there after clicking it. Don't worry about that. Just ignore. Here's the textbook, Catnell and Johnson Physics. Catnell and Johnson were the original authors of this book. Okay, and as they pass away or they don't want to write the book anymore, so Wiley, for instance, or any other publisher hire someone else to do the writing of the book. In this case, the original authors of the textbook was Catnell and Johnson, but now the present authors are Dave Young and Shane Stadler. I suggest that you get the ebook plus the homework access, the Wiley Plus platform. Last time I checked it was $69. I do not know if it's still the same price, okay? So let me put just a question mark here, but it's a reasonable price. You log into Wiley Plus using the link, this link right in here, and the course section, ID 90680. The instructions for accessing the course are right in here. Outcomes, modules. Homework Wiley Plus. Here's the flyer that I posted with the course ID. Okay. And it covers the step-by-step. Select add course. You don't have to buy access right now because Wiley Plus give you access for the first 2 weeks, I believe. For the first 2 weeks, okay? Once you start using. So you can check this other link again. Let me show you. File syllabus outcome modules. Oh, right in here. Is the one at the very bottom. Wiley Plus section flyer C90680. That's the course ID. For the homework problems, you need to access Wiley Plus online software. Course section ID. Log into Wiley Plus using the link and the course section ID, okay? It's a 4-unit course. 3 hours and 10 minutes of lecture and 3 hours and 10 minutes of lab. I put lab between quotes because those are, how do you say, make-believe labs. I like to refer to that, our online labs as make-believe labs. That's the prerequisite for the course. Class recordings are in my YouTube channel. And that's the address of my YouTube channel. I have videos since, since when we had the pandemic. I started posting videos there since 2020. Here's the link. Okay. I have a playlist. You might want to take a look at, let's see. Yeah, you may want to take a look at the playlist here. Physics 7, Physics 38, Physics 39, Physics 6, Physics 37. Okay. Physics 7 is this one here. They're all a bunch of videos there. They are very long videos because our class meetings are 2 hours long with the dates, saying whether it's a lecture or a lab. The links for those videos will be there in Canvas, in that Canvas page that you saw. Okay, let's do, just test the link. So let's see, the first meeting, 12 of February 2025, right? Here you go. If you click right in here, you're going to see the recording of that day, of that date. Computer. Here you go. Okay, here you go. This one is almost 3 hours long. Almost 3 hours long. Okay, course description. This is the second course in a two course. The second course of a 2-course series, right? Course series. The trigonometry-based sequence with physics 6. Topics include principle of electricity and magnetism. Very important, electricity and magnetism. If you want to understand today's technology, you have to understand electricity and magnetism. Optics and modern physics. Modern physics is the physics of the 20th century. Electricity and magnetism, let's say, is the physics of the 19th century. And optics has been around for a long time, right? It's at least the 1500s. Let's take a look in the internet, the history of optics. History of optics. Here you go. Wikipedia. Early history since the 5th century BCE, before Common Era. Okay. And in his optics, Greek mathematician Euclid observed that things seen under a greater angle appear greater, and those under a lesser angle while appear equal. Euclid was a philosopher, a Greek philosopher. Which year? All right. Let's take a look at Euclid. 300 BC. So the theory of optics has been around since antiquity, since ancient Greek. And even electricity and magnetism also has been around since ancient times, okay? It just happened that we did know about the static electricity. We did know about magnetism since ancient times. It just happened that the very basics of electricity and magnetism was concluded in the 19th century, in the 1800s. And the laboratory includes both quantitative and qualitative experiments, which permit the students to verify, illustrate, and deduce various laws of physics. Okay, those are the course objectives. It's 350. Okay, so let's give a little break, right? Let's get a little break right now. Okay, and then we'll continue. We're gonna have a break, 15 minutes break. That is 10:15 right now. Break from 10:50 a.m. to 11:05 a.m. And then after that, we continue covering the syllabus. And if you have time, we start with the material, okay? So I see you in 15 minutes. I am back here. So we were covering the syllabus. Okay, so course objectives. Relate the nature of electric current to electric charge and the resulting magnetic and electric fields. Everything that we're going to teach in this course is just the basics for you to understand more complicated things that you may find out in your professional life, okay? And apply each of Maxwell's 4 equations of electromagnetism and Lorentz force and the Lorentz force law to predict behavior of electric and magnetic fields. Okay, Maxwell's equations are what we called the laws of electricity and magnetism. Okay, there are 4 Maxwell's equations that we are going to formulate. Just remember what you had in the previous course, right? In the previous course, we covered those basic quantities, and I'm going to repeat that here, okay? The basic quantities, the primary definitions, and the laws of physics. Those are the 3 building blocks of physics that you must know to understand how physics is organized. And the Maxwell's equation is just 4 different laws of electricity and magnetism. Lorentz force law is also a law. Analyze a circuit containing sets of batteries. EMF means a battery, something that provides electric energy. Resistors, capacitors, and inductors. All those 4 devices, they are very important in electricity and magnetism. We are going to cover that. When either the voltage is DC or the voltage is AC, 2 different types of voltage. Voltage / current. Okay, the simplest type of circuit are the DC circuits. That's the easiest one to understand. Because of that, this is the first one that we study. When we talk about circuits, we start talking about DC circuits first. And later on, we introduce the alternate circuit. And we are going to describe the difference between those 2. Describe the derivation of electromagnetic radiation constraints from Maxwell's 4 equations of electromagnetism and the resulting property of radiation. That electromagnetic waves are intimately related to light. And the Maxwell's equations predict the type of electromagnetic radiation that you may have, okay? Generate the path of light rate according to the laws of reflection and refraction. That's where we're going to do in optics. Predict the behavior of basic optical systems constructed from lenses and mirrors, both graphically and algebraically. Analyze the situations involving interference and diffraction of light waves, and applying this to situations including double slits, diffraction grating, and wide slits. The student should be able to understand Einstein's special theory of relativity. We are going to cover that as well. We always have time to do that. Hopefully, we will have time to cover quantum theory as well, which is the physics of the 20th century. Those 2 are the physics of the 20th century. They were formulated in the 20th century. And knowledge of spontaneous and radioactive decay. Student learning outcomes, right, spelled out here. Okay, those are the summary of the links. This is the link for the class meetings, office hours, and the exam. Wiley Plus link. The class recording according to my YouTube channel. And lab folder, I'm going to provide you a link. I'm gonna make different, I'm gonna team up with another student, and that's gonna be your lab group. And each lab group is going to have a lab folder that's going to be in my Google Drive. So one more student. Here you go. So I'm gonna, let me write that down here, right? Lab folder to be provided by your instructor. Okay. I will team you up with another student, and that will be your lab group. Each lab group will have a lab folder with a link that the instructor you provide. The instructor instead of I, right? The instructor will have a lab folder. My Google Drive is a link that the instructor will provide. Okay. Okay, I have to erase that here. I didn't notice that. Okay, grades are based on lab attendance. Let's see, lab reports, homework, partial exam, and the final exam. Okay. Homework is done online using Wiley Plus platform, which is a computer software that allows you to solve problems online, providing you with automated hints and grades. The homework accounts for 8% of your grade, final grade. Subscribing to Wiley Plus is a requirement for the homework. Partial exams, there will be 3 partial exams during the semester, each of them 2 hours long. You should expect 1 partial exam every 4 to 5 weeks. 4 to 5 weeks. I will drop the lowest grade of this exam and take the average of the remaining 2 exams. This average accounts for 42% of the final grade. Here you go, 42% of 8% for the homework, 42 for the partial exam. All partial exams will be taken online on campus on Wednesday. You must be present, right? You must be present for the exams, for all exams, including the final exam, for all exams. All exams. Please advise me if you are a special student and need additional time. All partial exam, okay, gonna be Wednesday, 9:40 a.m., right? Why did I put p.m. here? 9:40 a.m. to 11:40 a.m. You must be present online during all exams. Final exam. The final exam includes all material covered and accounts for 25% of 25%. Let's see here. Yeah, 25% of your final grade. Failure to take the final exam will result in an F for the course. Please consult the final exam schedule, spring 2026, page 5 of the schedule of classes for the date of this exam. If you go online, let's go online so you understand how to access your exam. Your exam, the date of your exam. Here, this one here. Okay. Let's go to the homepage. Here's homepage of LA Harbor. If you want to take a look at the course catalog, schedule the schedule of classes, academics, schedules and catalogs, right in here, calendar and schedule. And then we have all the classes schedules for the winter 2026, the spring 2026. That's the summer 2025, no longer applicable, right? Fall 2025, no longer applicable. Okay, and that's the general catalog. What you want the schedule of classes for the spring 2026. You can open and download it to your computer. And on page 5 of this schedule of classes, we have the schedule of the final exam. Here you go. Okay. So how do you read this table, right? How do you read this table? The final exams starts on June 2nd, and the last day of the final exam is June 8th. Tuesday through Monday. And okay, our classes start at 9:40 a.m. Okay, start time of the class. Let me download that. Let's download it. I recommend that you download that to your hard drive as well. Go back to page 5. That's the final exam schedule. I'm gonna zoom in so you can see it better. Look for the days and time of the class. Our days is Monday and Wednesday. Okay, so this column here is for Monday or Wednesday, or Monday, Wednesday, Friday. I'm going to, let's see here. That's not gonna work. Let me, something is strange here. Let me try it again. Okay, good. Now I have in the proper format. Page 5. That's page 5. Okay, so you have to look at this column here, Monday and Wednesday. I'm gonna come up with this one. Let's see here. Red, better, okay? And 9:40, that's the rule. Start time of the class. So look here. That is the date and time of our final exam. It's gonna be on the last day of final exams, 8th of June. So consult this schedule of the final exams every now and then, because it may change, okay? I have since it may, I said may, I didn't say it will, right? You know, all those, I have been teaching here at LA Harbor since 2009, and since 2009, they changed this schedule only once. So you do the math, right? 2009 to 2026, we are talking about 17 years, 34 semesters that I taught, and only once they changed the date of the final exam, only once. Okay, most likely it is not going to change. Most likely it's not going to change. But let's keep on, you know, let us keep on checking every now and then during the semester. And go back here. Currently, the final exam is scheduled for 8th of June 2026 between 9:10 a.m. and 11:10 a.m. Note that the time of the final exam is different from the time of the, partial exams. The time of the partial exams, right? 9:40 to 11:40. And that 8th of June is what? It's a Tuesday, right? Let's see. 8th of June. Oh, it's a Monday. It's a Monday. The exams, final exam start on the 2nd, which is a Tuesday. And the final day of the final is 8th of June, scheduled for Monday. 8th of June, between 9:10 a.m. and 11:10 a.m. Also be online on Canvas. What else? At the day, all exams will be on Canvas. You must be logged into Canvas and the class Zoom link for the exam. You have to be in the Zoom link with your webcam on. For our exam, you must have a reliable computer, reliable internet connection, and a working webcam that must be left turned on all the time, point towards your face. A webcam is a requirement for this course. If you don't have a webcam on your computer, you may use the webcam of your cell phone while logged into Canvas from a computer. Arrive before the exam starts or you will not be allowed to take it. Exams are open notes, open book, but you cannot get outside help from anybody. Online lab activities. Due to the nature of this online course, there will be no hand-on experiments. Instead, the instructor will provide you with actual data obtained from previous experiments related to the course by other students. And you will work on this data to display it in the proper table format, plot graphs using Microsoft Excel. Okay, laboratory work is an important component of any science. For this reason, we designed a series of 8 to 10 experiments for this course to reinforce the concepts presented during lectures. Demonstrate in practice, and I'm putting practice here under quotes, right? The concepts taught, familiarize the students with various types of equipment available for engineering research purposes, demonstrate laboratory procedures and methods of data analysis using Microsoft Excel. You're going to need Microsoft Excel, okay? Installed there in your computer. Learn techniques to troubleshoot an experiment and to troubleshoot your data as well. The very important skill is the troubleshooting skill. Find what's wrong about the experiment or find what's wrong about the data. In our experiment, which I call make-believe experiment, you may work with another classmate, no more than 2 students per group, and you will submit a single lab report, and your group will submit a single lab report. Materials for the lab, bound notebook, can be electronic notebook. Let's put here bound/electronic notebook. Okay. For notes. You know what? Let me take it out. Yeah, it should be a bound notebook. Okay, a physical bound notebook. And use pen only, okay? Why is that? There's a reason. Here you go. Here's my physical bound notebook that I use for my experiments when I'm performing my experiments with my own technology, right? I'm documenting everything here that I think is important that can be used as evidence, future evidence for anybody that might be challenging the data that I collected. Okay, this is what you see right here is a legal document that was written in pen in the paper. Okay. A reliable laptop or desktop with Microsoft Excel and Microsoft Word for the, you don't need Microsoft Word, but you are going to need Microsoft Excel. Okay, for data analysis. Let's take this one out. Reliable internet connection, pen flash drive access to cloud, pen flash drive or access to the cloud to store data. Here you go. Pen drive, here you go. Flash drive or access to the cloud to store your data. In the case of a power outage, I recommend you purchase an UPS, uninterruptible power supply, and connect your computer monitor and modem to this unit. An UPS unit is a smart battery that provides power to your computer for a limited amount of time during blackouts and grayouts. I discussed that before, right? Laboratory reports. We are going to cover that in detail on Wednesday. But the lab reports consist of a spreadsheet that I'll provide you. If you took my class last semester, you're already familiar how I do the lab report, right? If you didn't take my class, you're being told right now that you'll be working a spreadsheet with a spreadsheet that I will provide for the lab report. Okay, each group of at most 2 students will submit a lab report consists of the Excel document provided, which is the spreadsheet with your actual data. Okay, and we're going to plot graphs. Most of the labs will plot graph. And this Excel document must be turned in before the date announced by the instructor. What's this date? Usually before the beginning of the next lab. The spreadsheet will be made available to you before the beginning of the lab. Your lab report is worth 100 points, okay? So like I said, I'm gonna cover that in more detail on Wednesday. Let's skip it for now. Okay, make-up labs and exam policy. There are no make-up labs and exams. If a school function or religious holiday conflict with an examination date, please notify the instructor at least 1 week in advance so he may reschedule the exam for the whole class. It's the student's responsibility to advise the instructor 1 week in advance of any school function or religious holiday. Failure to do so may jeopardize your grade in this specific exam. Academic and scientific misconduct. So there are 2 basic academic and scientific misconduct. One of them is plagiarism. The other one is data manufacturing. Okay. And believe it or not, we do find this type of misconduct even among professional scientists. Okay, at this very moment in my career, I am suing a group of professors for plagiarizing my technology. They are using my technology without providing any reference, any credit to my work. The side illumination technology that I introduced you to is being used by other university professors throughout the world, and even by a major corporation in the United States. At this very moment, like I said, I'm suing these professors in Brazil. Okay, they publish around 20 papers on side illuminated optical fibers, and they didn't give me credit for that, and they refused to give me credit even after I have contacted them. And at this very moment in time, I have 2 lawsuits against them. One in the civil court and the other in the criminal court in Brazil. Okay? And this thing is still going on, right? Hopefully I will find out the result in the next 2 years. Data manufacturing is something far more serious than plagiarism. Someone just make up data to get money from an agency, right? I witnessed something like that in my professional life as well. I'm haven't been very lucky about that, okay? And during the lab activities, you're supposed to work with the data provided to your group and report it accordingly. You must not copy or plagiarize data from other spreadsheets, nor manufacture data into your report. I will carefully correct your lab report to determine if there is any plagiarism or data manufacturing. For more academic integrity and plagiarism, consult articles published in the internet. And here's the boilerplate paragraph that we are supposed to add to the syllabus. District academic dishonesty policy. Violations of academic integrity include but are not limited to the following actions. Okay, cheating on an exam, plagiarism, working together on an assignment that was supposed to be done independently, paper or project when the instructor has specifically state students should not do so, submitting the same term paper to more than one instructor, or allowing another individual to assume one's identity for the purpose of enhancing one's grade. Okay, disability accommodation statement. Okay, if you have any disability, just let me know. Title 9, discrimination based on sex, including sexual harassment and sexual assault. Okay, there is this contact at Pierce College, Dr. Genesis Arcido Magruder. Class conduct. During the lecture in the lab, please turn off your microphone if you're not using it. Grading, here you go. Here's the grading. Percentage 990 to 100 is A, 80 to 89.99 is a B, and so on. Okay. Here's the estimated schedule. It's subject to change because depending if you fall behind some of those topics, right? I have to adjust the schedule. We do have a holiday next week. Next Monday, we have a holiday. We are writing here. Let me bold-face it here for you. Introductions, electric charge and force. That's what I want to cover today, start covering today. Wednesday, we are going to cover the spreadsheets and talk a little bit about the electric field as well. Okay, that's when we are going to have our labs, right? And let's take a look at how do I know that we have a holiday? Well, just look at the schedule of classes, right? The schedule of classes also documents the holidays on page 4. Holidays are documented on page 4. President days and non-instruction. Okay, here you go. Friday, February 13 through Monday, February 16. Okay. Okay, here we have a mistake, okay? If you go to your